All right, so welcome everyone. Thanks so much for joining us today. This is the second in our most recent webinar series, and today we're going to be covering random assignment in the Measures of Effective Teaching project, including implications for analysis of the database and relevant research. So my name is Joanna Blackman, and I'm one of the managers of the Measures of Effective Teaching Longitudinal Database Archiving project here at ICPSR. ICPSR is a unit of the Institute for Social Research at the University of Michigan. So I'm going to introduce our presenters, quickly mention our recorded and upcoming webinars, and I'll also show you where you can find MET project and MET LDB resources, and then I'll turn the presentation over to Doug and Matthew. So first, our presenters with us today are Doug Stager and Matthew Steinberg. Dr. Stager is the John French Professor of Economics and Chair of the Department of Economics at Dartmouth College, and he's also one of the original MET project partners. Dr. Steinberg is Assistant Professor of Education at the University of Pennsylvania with appointments in the Education Policy and Teaching, Learning, and Leadership divisions. So I'm really thrilled that they're here with us today, as they are really incredible resources for digging deeper into the MET data and understanding this very complex collection. So thank you both for joining us. So before moving on, just a quick pitch for our recently recorded and a few still upcoming MET webinars. So in September of last year, we presented an overview of the MET project that was given by Carrie Kerr from the Bill and Melinda Gates Foundation, along with myself and another colleague here at ICPSR. I encourage you to visit the LDB website and ICPSR's YouTube channel to watch that presentation. It'll give you a good sense of the MET project itself and the data files available, and also the data access process. Last week, we presented a webinar on the logistics of accessing and scoring the video data, along with a discussion of how the video and quantitative data relate and how they can be linked. Just yesterday, I believe it was loaded onto our YouTube channel that Linda mentioned, and I encourage you to check that out as well if you intend to use the video data. So today's presentation is of course listed here also and will be available for viewing in the coming days as well. Upcoming presentations will focus on the video collection and scoring processes in the MET project, and that will be instructed by the MET partners who directed those processes. We will also feature a webinar on in-progress secondary analysis projects. 3 of the MET early career grantees will discuss their work, lessons learned about the database, and preliminary findings. So please do sign up for those. We'd love to get all of your MET questions answered, and there's still space available. So I'm going to switch really quickly here to the MET LDB website. I just want to highlight really quickly the resources that we have available to help you better understand the project and the database. First, I'll point you toward our listserv. So if you click on this link in the upper right corner and give us your email address, we don't send out too many emails, maybe once every couple months, just updating folks on presentations or data trainings like these, in-person trainings, new data available, things like that. So that's one of the best ways to keep up to date with the MET LDB. I'll also point you towards our announcements section. Similar information that you'll find via the listserv will be posted here. Our documentation section is probably the richest resource that we have available to you. The user guide is a really fantastic resource. It provides a very good overview of the MET project, along with in-depth discussions of many elements of the project and the database. We also have code books available for all of the MET data files and many of the instruments used as well. I think I can show you an example. Yeah, so we have questionnaires. Not all of them are publicly available, but some of them are, and you can find them on the website here. Finally, I'll point you toward the related resources page. So we have linked here all of the MET project reports and briefs from the Gates Foundation, along with all of the recorded presentations and webinars that we've hosted. They're up here. Stay tuned also for additional resources. My team here at ICPSR has a slate of resources to create and publish in the coming months, so there's more to come. Okay, I'm going to pass you folks over to Doug Stager now. Okay, Doug.
Okay, let's see if I can get this to work. Is it showing? Yes.
Yep.
Good, and you can hear me?
Yeah, we can.
Okay, good. So my job is just briefly here to give you a high-level overview of the randomization in the MET project and kind of what the main issues are and things that you can do with this data at a very high level. I was one of the, my role in the MET project, one of my main roles was doing a lot of the empirical analysis on the randomization paper and that project. So I've been immersed in this for a couple years. So I'll give you an overview, but you can certainly ask details later. So let me start just with an overview of why we did the random assignment, what its goal is. And so we started out by randomly assigning just under 1,600 teachers in grades 4 to 9 to classrooms in these 6 large districts. We started with closer to 3,000 teachers who were participating in the MET project. These were teachers who were still there in the second year, so the randomization occurs in the second year of the project, and where we still had enough teachers within the school, I'll talk about this in a second, to randomize. We had to do randomization within grades and subjects in a school, and so you had to have at least two teachers participating in that grade subject, and sometimes we lost people because we lost enough teachers in that school that only one was left in that cell, that randomization cell. So the goal, why are we doing random assignment? I think the key to think about this is the randomization provides an experimental estimate of a parameter that we care about. And I always try to be really clear what we're going to learn from this. The idea is if you took a given classroom of students and they were to have teacher A, one teacher, rather than teacher B, how much different would student outcomes be at the end of the year? And the experiment was designed to be able to get a good, clean estimate of that. And the reason we always worry in observational data, we're worried that the estimates we get of that are biased because of students sorting to teachers. Teachers get different kinds of students and get that year after year. And the idea of the randomization is we break that link. There's no sorting. We know students are random, or we know classrooms are randomly assigned, so no bias. Once we have that estimate, what we were interested in specifically in the MET project was to evaluate whether observational, pre-experimental, the first year of the study, observational measures of teacher performance could predict these experimental results. So the observational data, you worry, might be biased, might have all kinds of trouble, but you can validate it by looking to see whether it actually predicts actual outcomes when you know there's no bias in the randomization. So that's the motivation for the random assignment. The next, the actual random assignment is very simple, and so this slide just summarizes it and actually then what we did with it. The key is that at the beginning, we have these teachers who could be randomized within a school. Think of it as 3 fourth grade teachers in a school, or 3 7th grade math teachers who the principal said could be randomized. Their schedules accommodated randomizing them to classrooms. For those teachers, the principals created rosters for each class. And the key is think of that's going to be the key roster data that you start with. Those are the people we intended to have, the classrooms we intended to have assigned to each teacher. We got those rosters in the summer or sometimes late spring from the schools. We flipped coins. We randomly assigned the teachers to the classroom rosters. And that's the key. It's done within each grade and subject. And then that's the randomization data And then there's, what we were interested in was we had, based on these observational measures of teacher performance, we could predict what student outcomes should be in each of the classrooms based on which teacher they got, and see whether our predictions aligned with what you saw under randomization. So that's the structure of the randomization. After randomization, we have, there are all the classic problems in experiments. Some people don't comply. Some kids disappear. There's missing data. So attrition issues. And I'm going to talk especially about the compliance. So all those problems are still sitting around. Let me just say make kind of some broad points about the external validity, who's this experiment, and is about. I know Matthew, I think, will say more about this. But the key thing with external validity is that this randomization is within school. In fact, it's within grade and subject. And so there's nothing in this experiment that's going to let you think about our measures for trying to compare between school teacher performance. There's nothing in this experiment that lets us think about the between school the between school differences. So we were able to say, oh yeah, a teacher who looks better in this school compared to another teacher in this school, in fact, that translates into student performance when you randomize them. But we don't know if that teacher will look good if we put them in a different school. The experiment just can't answer that question. In other senses, the experiment has pretty good external validity. We were always worried that we'd get only good teachers would volunteer to participate in the experiment, but that wasn't true, at least in terms of value added. The participating teachers looked just like other teachers in these districts. The one place where where the sample participating in the randomization is a little different is in terms of special ed and English language learners. They're underrepresented in this sample, and that's because principals often could not randomize. They'd have a particular teacher who had certification in special ed or English language learners, and they couldn't randomize classrooms for that teacher because they only had one teacher like that who had that certification. So because of that, because we basically undersample special ed and English language learners, you can see like the randomized rosters, the kids who are in the randomized rosters in our randomized sample have somewhat higher baseline test scores, and there's a little bit less. One thing we were interested in was how much sorting there was among the classrooms and among the teachers who were participating in the experiment, and in particular, in the past, were these the kind of teachers who had been getting sorted high-scoring kids or low-scoring kids year after year? And the evidence was that the teachers who participated there was a little less sorting, but there was still a lot of sorting going on in the prior to randomization. So, we were concerned. We didn't want to get only teachers participating who were the teachers who were having kids randomized to them anyway. That didn't look like the case here. So, in general, pretty good external validity with this one exception, the first point. Let me then, the last big thing to think about, I'm not going to talk about attrition, missing data issues, because those turned out to just not be the major headache. Instead, let me talk about compliance, which I think is the biggest issue that you'll have to worry about and address in the analyzing the randomization data. So there was a lot of non-compliance. And what I mean by that is we randomized a teacher to a roster, to a classroom roster, but then in actuality, many of the kids who were assigned to a teacher weren't with that teacher. And that happened for a number of reasons, and it varies a lot. Some districts were great, some schools were great, others were disasters. And that both happens because individual students, one or two students will switch out of the teacher's class, after random assignment. It also happens because a lot of the non-compliance was whole classrooms not being with the assigned teacher. And we think a lot of this was logistical issues. So for example, in middle school, when kids change their schedule, they have to move. right? Their whole schedule changes and they're no longer in 7th period math. Many of the places had logistical problems like after we did random assignment, some teacher left or they had to add an extra class, and so they redid all the classes, right? And so suddenly our rosters were totally overtaken, right, and they just used completely different rosters. The other thing that happened was when we got reports back from districts that people would say that after they sent us the rosters to randomize, after we randomized and sent them back, they'd say, oh, but we already sent them to parents. They just didn't understand the randomization process. And so after they sent them out to parents, they couldn't change. So in all the analysis, the key is we have to work with the assignment, the rosters as assigned, right? We can't say, oh, well, we'll just use it as they actually landed. That's observational and not randomized anymore. So think of the original roster data is the intention to treat data, but the problem is it's going to underestimate if you think that you assigned a classroom a really good teacher. In fact, the kids who were assigned to that teacher on average won't have the really good teacher. Many of them will have switched into a different classroom. So if you just do intention to treat, it'll underestimate the impact of having an effective teacher. So, to handle this, so you got to both be aware of this. For some purposes, that's okay, and you can just do intention to treat. For our purposes, we were interested in for example, the impact of having a good teacher as measured by certain, performance measures. And for that, you got to do some kind of adjustment for the non-compliance. So, if I assigned you to a great teacher, but only 30% of kids got that great teacher, I need to take that into account in thinking about what the impact was of getting a great teacher. So we did that using IV, using your assigned teacher as an instrument for your actual teacher, and use that to adjust for noncompliance. And if you use that approach, then again, you have to think about interpretation. This is now late or local average treatment effect interpretation, where the estimates are all relevant for compliers, for people who complied with the experiment. And so you may not be learning about whether you'd see the same effect in the people who didn't comply. And that's, those are the kind of key issues that you've got to think about in analyzing this. Let me stop there. That's my kind of high-level overview.
Okay, so I'll pass the screen over to Matthew now.
Okay.
All right.
So I will hit show my screen. All right. Joanna, can you see my screen?
Yep, sure can.
Okay, great. Doug, Joanna, thanks very much. So I think Doug's done a really nice job of framing the high-level issues, and what I'm hoping to do is provide a little bit more granularity around both the data that's available and also examples of how you can use the data to answer some of the questions that Doug has summarized. So just a bit of an overview. So again, I'm going to summarize the project itself, and then the questions that the project aimed to answer, and then go into a bit more detail about the study design and the randomization sample itself. Then for the purposes of identifying the specific files and variables that can be used when analyzing for analyzing the randomization data, we'll talk about the files and the variables that are included in those files. We'll talk about some questions that randomization can address. So Doug has talked a little bit about this already, and I'm actually going to use two examples to discuss the types of questions that randomization can answer. One from Doug and Tom Kane and others' paper from the MET study, and then a paper that I've just completed that's forthcoming that uses the randomization sample as well. Then we'll talk a little bit about analyzing the randomization samples. I'll just provide sort of a general overview of the types of analytic approaches that the MET data allow for. And then Doug has begun to talk about this as well, the generalizability of the findings, which is really key. And so I'll provide a final word about who the results of any analysis with the MET data are generalizable to. given that, as you'll see, the randomization sample is a subsample of a subsample. So we'll get into that in a few minutes. And then at the end, we'll provide some opportunities for Q&A. So again, the MET study, the MET project, the largest study of classroom teaching ever conducted in the U.S., and it was designed to address a range of questions. So again, this is a bit sort of broader than just the randomization sample, but things like how reliable and valid are specific measures of teaching effectiveness, whether they be from classroom observations of instructional practice or value-added scores. To what extent do various measures identify distinctive dimensions of teaching effectiveness, right? And if so, what dimensions are identified? So for example, using the classroom observation scores, can certain types of instructional practices be distinguished and be identified as more or less effective than others? What measures of effective teaching are empirically related to student learning gains? So this is some of the work that Doug was beginning to describe. And then can multiple sources of data on teachers and their teaching be combined to develop a set of fair, valid, and reliable indicators of teaching quality, which is particularly relevant as new teacher evaluation systems are rolled out at a national level. So again, a bit about the study design. In 2009-10, select classes of participating teachers were included in the first wave of the study. So this first wave allowed researchers to construct measures of teaching effectiveness, assess the psychometric properties of various measures of teaching effectiveness, and also to begin to generate some correlations between observational and other measures of teaching effectiveness and student outcomes. So I think the key here is the correlation, right? Because then in 10-11, as Doug described, these classes of students were randomly assigned to teachers to enable causal inferences about, again, teaching quality and teaching effectiveness, as teaching effectiveness is measured with respect to student learning outcomes. So a bit about the MET sample itself, and this data comes from the user guide, from White and Rowan's user guide. So as Doug mentioned, in year one was the first year in the full sample. So this full sample straddled 6 districts with a subset of schools totaling 317 schools, about 3,000 teachers, in about 4,500 different class sections. So you can think of about a class section as, for example, a 7th grade math class. And multiple teachers certainly are teaching, in many cases, more than one class section. Then there was the year 2 study, which again was a subset of the full sample from year 1, which again was across 6 districts, 310 schools, about 2,000 teachers across about 2,000 class sections. And then as we see with the randomization sample, right, this is a subset or a subsample of the year 2 sample, right? So fewer schools, fewer teachers, and fewer class sections. So let's talk a little bit about the MET data itself. So what data is actually available? I imagine many folks have hopefully had a chance to take a look at the user guides and available data files. So there are district administrative records, right? So school, teacher, and student level data, which includes demographic characteristics on the teachers and the students, as well as students' test score outcomes from both the state-administered tests as well as MET-administered tests. There's survey data from both students, teachers, and principals. So the students took the student perception survey, the tripod survey, so Ron Ferguson's tripod survey. Teachers took 3 different surveys in 2 different years. So in year 1 was the teacher working conditions survey. And I'll talk again about where you can find these various data variables, data elements in the data files themselves. Teachers also in year 2 took the content knowledge for teaching assessment and a MET-administered teacher survey. And then also in year 2, there was a principal survey which provided some information about those principals, teachers who were participating in the MET study. And there were also classroom videos, and these classroom videos were key to enabling the scoring of the observational scoring of teacher practice. So each video, whether it was from a math or ELA lesson, was coded with the class and the framework for teaching, Danielson's framework for teaching. ELA sessions were also coded with the Plato observational instrument. Math sessions were coded with the MQI instrument. And then there were also biology sections that were coded with an observational instrument, the QST. So again, this is just a sort of a broad overview of what data exists. And what I'm going to talk about now is the relevant data and variables that you can use when you're analyzing the randomization files. So the first file of interest is going to be the class section file, right? So this class section file includes the following, what we call section level data. And again, section is just a class itself. So this again could be a 7th grade math section. So there are district, school, teacher, and section IDs, right? So as you're going to be likely merging files across, or merging data across these files. So there's, for each class section, there's a unique district ID, unique school ID, unique teacher ID, and again, this is the actual teacher ID in that class section, and the section ID itself. And again, you might ask, well, why do I need a teacher ID if I have a section ID? But again, keep in mind that many teachers teach multiple class sections. In the class section file, you'll also find information about the grade, subject, and year. So 5th grade, ELA, 2010, for example. There's information about the randomization block, right? So if this class section was included in the randomization files, what was the randomization block itself, right? So again, as Doug described, the randomization block is going to be a unique grade-subject combination within a school, right, which is the level of randomization in the randomization sample. There are also section-level student aggregates. So, right, so demographic and achievement aggregates. So these are effectively the mean characteristics of that class section. There are also section-level teacher observation scores from the multiple classroom observation instruments that were used to score teacher practice in a variety of subjects. And again, these are aggregated to the class section. And what we'll see in a few moments is that there's actually specific scores that you can obtain for each of the observation scores themselves. Although I'm realizing I don't have that in the slides, but there are actually specific scores that you can obtain for the raters. So that, and then finally there's the teacher value-added scores for math ELA and also for the MET administered exams. So these are for the 2008-9, 9-10, and 10-11 school years. And these are value-added estimates that were constructed by the MET researchers. So there's value-added estimates that account for classroom composition as well as unadjusted value-added scores. So you want to pay particular attention to which value-added scores you may be using in the data. And then finally, there are student perception survey results. So these are the student survey results that are aggregated to, again, the class section level. So that's the class section file. Next, we have the student randomization file, right? So this is going to be the file that's going to be particularly relevant for you all who are going to be using the randomization sample. So the student randomization file includes the following variables. So again, there's district, school, teacher, section, and now student unique identifiers. There are student level demographic and achievement data. So again, this is at the student level, whereas the class section file is at the class level. Student survey responses. So here we've got individual survey responses by student within class and within a teacher. And then key to understanding, as Doug was describing, the nature of noncompliance and student sorting are the randomly assigned teacher IDs, which can be obtained from the randomization file. And so there are 3 IDs that are going to be critically important. The first is the teacher ID for the teacher that was randomly assigned to a particular student's class. And again, it's important to keep in mind that these are not individual student randomization matches. That is, students were not randomly assigned to teachers, but the teachers were randomly assigned to classes, right? And then we also know, or we can also observe, the actual teacher that a student had in May of that school year, and also the teacher that that student actually had in the fall of that school year, to see a number of things. First, if you compare the randomly assigned ID to the October ID, you can see the extent to which students complied with random assignment. And then you could also see the extent to which there may be within school, or rather within year sorting, right? So if the teacher ID varies between May and October, perhaps that student was reallocated across classes within the same school year. So we're beginning to see a number of sort of within school dynamics that can be observed just within the context of these three teacher ID variables. And finally, we have the teacher file, right? So this is going to include the district ID, the school ID, and a teacher's unique identifier. Again, these identifiers are unique to teachers, but can be linked across the data files. There's grade, subject, and year information. There's randomization block information and a variable indicating whether that teacher participated in the year 2 randomization sample. Teacher demographics and background characteristics, such as gender, years teaching in the district, master's degree status. And there are also teacher survey responses and principal survey responses that are included in the teacher file. So let me move on to an example of questions that the randomization sample can actually help to address. And for these, I'm going to talk very briefly about Tom Kane, Dan McCaffrey, Miller, and Doug Staker's MET research project paper. And then I'll get into a bit more detail as a way of exemplifying the type of work that you can do with the randomization data from a paper that I have forthcoming with Rachel Garrett. So in a first paper, one of the first papers or reports out of the MET project, Kane and others looked at whether we're able to identify effective teachers, again, leveraging the randomization of teachers to classrooms. And that work answered 2 questions, and hopefully folks have taken time to read that report carefully. So the first question is, did the measures of effective teaching successfully identify teachers who produced higher student achievement gains on average? Right? And again, keep in mind all of the non-compliance issues that Doug described and how that generates a difference between the intent to treat effect and the treatment on the treated effect, right, generated as a result of the non-compliance of some students to their randomly assigned teachers. And then did the magnitude of the differences correspond, as Doug described, to what we would have predicted based on their pre-randomization observational measures of teacher effectiveness? Now, our work looks at whether we can actually identify effective teachers based solely on their observational instrument, the framework for teaching, right? And the motivation for this work was that given that most teachers nationwide, something like 70% of teachers nationally, won't have value-added scores, right? The question that motivated this paper was whether just the observation score itself can identify effective teachers. And again, follows closely the work that Tom Kane and others and Doug have done using the MET data. And so the data that we used for this paper includes the teaching practice measure from the FFT, the Framework for Teaching, section, teacher, and student-level demographic information, and student-level test score data. And what we did was, again, we leveraged the randomization of teachers to students, right, and use an IV strategy, pardon me, to address not really the potential, but the actual non-random sorting of students post-randomization. And so we do 2 things, right? So we're going to first be interested in measuring observed instructional practice. So we look at, again, using the multiple dimensions or components that underlie the Framework for Teaching instrument. And again, most of these observational instruments have multiple dimensions that you can explore, right? Trying to understand one measure of effective teaching. And then critical for the randomization sample is accounting for non-compliance, right? As Doug mentioned, there was quite a bit of non-compliance, as many students, for a myriad of reasons that are actually unobservable for the most part, did not comply with their initial random assignment to teachers at the section level. So again, as Doug mentioned, if student non-compliance is non-random, then teacher characteristics, that sort of teacher quality, that teacher performance composite, if you will, that we're trying to randomly assign to classes is no longer orthogonal or uncorrelated to the composition of students at the class level, right? So then IV strategy helps to circumvent this non-compliance problem. But again, keeping in mind, as Doug mentioned, that the estimate that's being produced through the IV strategy is going to differ from an estimate that would be produced in a world where 100% of students complied with the random assignment. So just a little bit about analyzing the randomization sample, because I imagine there are a number of purposes that folks will have with the randomization data. But so it's going to depend on the question of interest, right? So the two examples that I've just mentioned employ OLS techniques as well as IV strategies for uncovering the causal effect of teachers, for identifying effective teachers. But what's really nice about the randomization sample is that it allows for comparisons across students within the same school, grade, and subject, right? So what tends to be problematic in studies of, for example, student sorting or teacher sorting is that we're generally making comparisons across schools, and we know that there's quite a bit about schools that we don't observe, right, that may bias those estimates. So these within school comparisons help to sort of purge the estimates of these of what's unobservable at the school level. So some may take a fixed effects approach, right, which is going to allow researchers to account for all unobservable characteristics at the level of randomization. Others may take a random effects or a hierarchical approach, which allows for examination of the extent of heterogeneity across and within randomization blocks within these schools. So again, a number of different approaches can be taken. We can have a whole, an entirely different webinar to talk about these approaches. But again, just an overview of the things that could be done from an analytical perspective with the data. And then just a final word to follow up on what Doug had mentioned earlier about the external validity of these findings. And while Doug was talking about sort of comparability of teacher effectiveness across schools, I think what's also particularly relevant is the fact that the MET sample is, as a randomization sample, as I mentioned earlier, is a subsample of a subsample, right? So the full MET sample, the year one MET sample, included a non-random subset of all teachers and students within each of the 6 participating districts. So for those of you who are used to working with district-level student data for the entire district, right, those findings may be generalizable to all students in that particular district, which is not the case here, right? So we've got the full MET sample, which was a subset of each of these 6 districts. In addition, the year 2 randomization sample, as we saw in the table earlier, was a subset of the full MET study sample. So we really want to be careful here about the populations of students and teachers about whom conclusions may be drawn. And often people take table 1 in a paper as a throwaway table. The summary statistics table is a very key table, I think, for contextualizing the results of your study, right? For really fixing ideas about who both students and teachers and schools are included in your analytic sample. So something to really consider about the generalizability of the findings from whatever analytic sample you draw from the randomization sample. So with that, I'm going to stop here, and I'll turn it over to Joanna, who's going to sort of moderate the Q&A.
Sure. Thanks, Matthew. So we have one question here. Folks, definitely send in your questions if you have them, but I'll read this one to you guys. So this participant is wondering if the two of you have any comments on an article that was recently published, Instructional Alignment as a Measure of Teaching Quality by Polikoff and Porter, published in Educational Evaluation and Policy Analysis.
I'm not. When was that published? And is it using the MET data?
It just came out using the MET data. Can you hear me? I just want to be sure.
Yep.
Oh, yeah.
I think it's a little orthogonal to the randomization issue. I'm actually not, now I'm trying to remember if they actually even use the randomized sample. But that, I think the most relevant part of that is this issue that Matthew was just talking about what sample do you end out with your analytic sample, in your analytic sample. So one of the key things in that paper is so they had a survey of teachers, and they're trying, so I don't want to go into too much detail, I just want to raise this one issue about external validity. So they had a survey, and they brought in an additional survey. So one of the things that's floating around in MET is there are these other data pieces that haven't been used, and those guys had, as part of the MET project, had done this survey of teachers. Just it took a little while for that to get done, and so it didn't come out as one of the original MET papers. But the big issue for them was they got something like a 35 or 40% response rate, and the resulting sample looks quite odd in a number of dimensions. And in particular has a lot less variation in the performance measures than what you see in the MET, in the broader MET sample, and less correlation, like the correlation across different performance measures was much lower in their select sample than the broader sample. So regardless of, I think a key issue in using this data is sometimes you'll pick a data element that was not collected on everybody, including in the randomization study, and you want to be really careful to think about, did you just select yourself into a small, narrow sample? Let me give, one place where this comes up that I didn't talk about, but that came up a little bit in Matthew's talk. A number of things in the second year of the study are only collected, so we have the randomization sample, but a number of the data elements that you might be interested in looking at are only there for teachers or students who are in participating MET teachers' classrooms. So for example, all of the special MET outcomes, the tests that MET gave, the auxiliary, not the state test, but the auxiliary tests, the student survey, those are only there for the MET sample, and that turns out to be, that's only for about 60% of the sample. You lose 40%, and in high school you lose 50%. And that suddenly makes it, think of that as missing data or attrition. So that's not noncompliance, that's just missing data. And that suddenly can cause a lot of trouble potentially. You got to be really careful now to think about whether you still have a representative sample in the remaining data. And I think that's true whenever you start bringing in another data element into thinking about the randomization. You have to be really careful if it starts dropping a lot of observations, both to think about, do you still have good randomization in the sample left, and just thinking about external validity. So that's internal validity. And external validity, do you still have a sample that is at all representative of teachers in general?
And just to follow up, I was actually looking up that paper, and the total teacher sample is 701. So, which is clearly very different than, quite a bit smaller than the samples we were already talking about. So I think Doug's point about the extent to which this is representative just of the MET study is something to be aware of.
Yeah, and it's not, and that's just, I just think that's, in a lot of these MET, it should be, one of the first tables should be how yours, how your data, whatever data is in your final analysis, both compares to the MET in general, and then there are these tables in the MET studies showing how the MET compared to overall.
Yeah.
All right, I'll read the next question here. So the participant asks, if I want to calculate value-added scores myself, do I need district-level data file? I somehow remember district-level data did not receive consent from parents and students. Is this a big hurdle?
So this is a question I actually have. Is this, Joanna, that I don't know whether ICPSR has made available the district-level data files that we had to construct value-added.
So we have made available the district level files. We look a bit more closely at folks who are submitting applications to use them because there's sort of a limited number of reasons that we can, for which we can provide access because those data are governed under FERPA. Yep. So the answer is yes, but there's a few more stipulations.
And let me say a couple follow-up things. One is, you don't necessarily have to have those. When we, when in the MET study, when we calculated value added using the state tests, in the first year of the study to do that, we did use the entire district file, but when we calculated value added based on, we did some calculations of value added based on the tests we gave, the alternative tests. Those were done just in the MET sample, right, with the MET students. And so I think you could probably do value-added estimates within the MET sample, within the more limited, smaller sample. It would certainly be preferable to do them more broadly, use the whole district when you're doing it on state tests. And the other thing is, we also, for the MET study, we used value-added estimates from the year before the study for some purposes. And for that, you'd certainly need the district-level data.
Okay, next question. Can you say a bit more about the fact that teachers are randomly assigned to intact classrooms versus students being randomly assigned to teachers, as in, for example, the Project STAR data? Intuitively, what are the consequences of this for analysis?
Do you want me to take that, Matthew?
Yeah, please.
Yeah. So, it's interesting. So I guess I can tell you why we did it and what the reasoning was. I'm not sure it makes much of a difference from an analysis point of view. It probably makes more of a difference from an interpretation point of view. So why we did it was that we were concerned and had heard some from principals that they want to create classrooms. They didn't care what teacher got it, but they wanted to put certain kids with other kids, right? I want to create nice, cohesive classrooms, and then I'm okay letting you randomly assign teachers to those classrooms. So the idea was that if we let them do that first, and then we randomize teachers to that, that would be, from an educational perspective, the principals were okay with that, where they were some principals were less comfortable with us randomly assigning individual students to the classrooms. So that was the logic behind it. I think, from a practical perspective, I'm sure we would have had similar poor compliance had we randomized individual, given how bad the compliance was in the MET study. I suspect we would have done similarly badly had we randomly assigned individual kids. And that was kind of our biggest worry, was by randomly assigning individual kids, we might be worried that the principal would undo a lot because they'd want to have cohesive classrooms. So if we randomly got misbalanced gender, misbalanced race, the principal might undo that. I think probably in hindsight that maybe wasn't the primary concern. From a practical perspective as well, I think it was easier for the principals to think about making up classrooms and then letting us assign teachers rather than us trying to do the whole student stuff. So I think, the only question is, from an interpretation point of view, is there any, difference in interpretation? And I think probably the difference would be subtle. It would be of the sense that some of the, this won't be correlated with the teacher you were assigned, but within a classroom, there might be some kind of a classroom effect that reflects, that reflects the way the classroom was put together. So if you see not a teacher effect, but a classroom effect at the classroom level, That won't be correlated because we randomly assigned it, but there may be a big classroom effect that wouldn't be there if we were randomly assigning students, or the opposite, right? So I think it'll be hard to generalize from the randomized data about the classroom, like in a hierarchical model sense, about the classroom level effects, because those are, those are at least, I don't know, those are consistent with the way that the principal built the classrooms. Maybe that's a good thing, but they aren't what you'd find if we just randomly assign kids.
So that was our last question. Please do send in more because we have a few more minutes. So I'll wait a second, see if we can get a few more. Okay, well, it looks like that might be it for now. Thanks, everyone, for joining us, and a big thank you. Oh, hang on, did I get another one? Haha, here we go. This is slightly off topic, but maybe still permissible. Does Doug know when exactly student surveys were administered within the year? Does that go on? No, that's it.
Yeah, so they were spring. They were administered in the spring, so they were kind of supposed to be, like tests, kind of end-of-year student questionnaire. And there were no, we thought at one point about trying to do a beginning of year and end of year and doing a value-added kind of measure where you could control for their perception at the beginning of the year, but we didn't do anything like that. So they're all spring student surveys.
Okay, I have one more here. I wonder if they can talk about making VAM comparisons across districts if possible.
Making VAM comparisons across districts. So there's two ways to think about that. One is on the VAM tests that were based on state test scores. And by the way, this is similar, this creeps over into all the measures of teacher performance, making comparisons across districts. You start to, it starts to raise questions. But on the VAM, the way we tried to make them comparable was by standardizing all the tests to be mean 0, standard deviation 1. We ran the VAM model separately by district. And then those were the VAM measures. Similarly, think of, because we ran the VAM model separately by district, VAM in each district was mean 0. So even if your teachers in one district were way better in some sense, we took that out by estimating VAM. So when we were thinking about other relationships between different measures of teaching and trying to pool across districts, we had to be sure that we took the mean out of the other measures as well, the district level mean. So, just the fact that all of one district looked better on frameworks for teaching, that would not be related to the VAM measures that we created by construction because we took the mean out. You can get around that potentially with if you construct VAM based on the alternative tests. Because the alternative test, the same test was given in all districts. And so you don't necessarily need to take out, a district mean. You can start to do, you could have one district, all the teachers' VAMs are higher than another district. But in fact, what we did in the MET study was we just did it consistently. We always estimated VAM models separately by district, but we didn't have to do that. So that's kind of I think that sums up trying to do VAM comparisons. Because you're right, no necessary reason to think that those are comparable. In fact, we found that they seem to perform comparable. At least you couldn't reject that the relationships between measures and the variance in measures and stuff were similar across the districts.
Are there any significant differences between conclusions that could be drawn between or across middle and high school teaching?
It's a good question. I think that's probably an under-researched question. Matthew, did you guys do anything with that?
You know, our sample included in the first paper just grades 4 through 8, so we could generate the value added for kids. Yeah.
Yeah. You know, when we did we had some things where we tended to split high school out because we didn't have state tests on them. We only had the alternative. You know, there's no standard state test in 9th grade, unlike grade 4 through 8. And at a very loose level, saw very similar kinds of results and patterns in high school as we saw in the younger grades. But I think there's work to be done there. We did not. That was not a focus. You know, we did some very straightforward things that, you know, on that, but didn't focus. We did more on elementary versus middle, and largely couldn't find significant differences, although, you know, that doesn't mean the estimates were always exactly the same. And there were some significant differences, like certain measures are more variable in middle school. I think the students, the tripod student survey measures vary more across classrooms in the middle school grades than the elementary, which you might think if you know middle schoolers. But we didn't, none of that was a focus. So I think a lot of that is open. The key issue is, and this is part of the reason we didn't focus on it, is having power to detect those differences, right? I think for some questions you'll have power, but, you know, if you start cutting up the sample into really small, you know, grade by district, you may see differences, but it'll be hard to be sure that they're significant. You won't have a lot of power.
From your perspective, Doug and Matthew, what are some of the major topics left on the table for secondary analysis after the first round of MET research?
Matthew, you want to take that first?
So Doug is less constrained on this question than I am, given our tenure status. But I mean, I think that there's quite a bit. I mean, I think certainly there are these questions of noncompliance. And where do kids go? You know, do they stay with their randomized teacher or not? In fact, we're looking at that question right now. You know, there's a variety of questions about the extent to which certain instructional practices may be related to outcomes for certain types of students. Again, that'll be more of an observational or correlational analysis unless you can disentangle that effect using the randomization sample. So I think that there's a lot to understand on both the instruction side as well as the student mobility side.
Okay, and then are you done? Should I follow?
Yeah.
So I agree. This thing about understanding compliers and non-compliers is I think potentially interesting. There's some good stuff to be done there. The things that are high on my list. So one is, you know, I think validating ways of better scoring the video or the student surveys. You know, there were very particular ways of looking at the video, of aggregating the scores, of aggregating the particular questions on the student survey that we imposed in the MET study. And there are wide open questions about, could you do that better, right? You know, and there's a ton of video there for people to figure out better ways of identifying what's really going on. And kind of like Matthew's study, also breaking the overall measure into different dimensions in meaningful ways that can predict outcomes. The other one that I think is big is looking at other outcomes other than test scores. You know, so we have all these teacher measures. How are they affecting, you know, we looked at some other outcomes in the MET study, but I think it's still wide open. And trying to estimate in observational data teacher impacts on, you know, non-test score outcomes, whether it's absences or suspensions or whatever it is, and trying to see if you can both develop those measures and validate them. Do they predict in the randomization? I think there's just a huge amount open there, and people are really interested in non-test score impacts of teachers and trying to capture those. And then last, I think there's a fair amount of data that got collected that was not used very much, including the principal surveys, which that principal survey included ratings of teachers, and just most of that data just ended out not being very used. So I think that's another aspect, right? And I think there's a teacher survey in there too that was not particularly, focused on in the first wave of analyses.
So the next question reads, a little off topic, but what are your concerns about current teacher evaluation policy reforms, especially related to your MET research findings?
I mean, I could just speak about the paper that I talked about, this forthcoming EPA paper, and that is that, I mean, at least from what we found, and again, it's going to be restricted to a certain sample of teachers, but there's limited ability, at least from the MET data, to identify causally effective teachers just using the observation score, which is different than what Doug found using composite measures of teacher performance, surveys and VAM and observation scores. So I think, and we argue in that paper that as teacher evaluation reforms move forward, greater recognition needs to be given to the fact that most teachers nationwide will only have observation scores, or overwhelmingly their summative evaluation scores will be based on classroom observation scores. And we also find similar correlations, year-to-year correlations among the observation scores that are found in the VAM literature, right? And so far less attention is being given to that year-to-year variability that's generated by the context-specific nature of instruction, the year-to-year differences in classroom composition, and so it limits, I think, our ability to say something and make personnel decisions about teacher effectiveness in this sort of new evaluation landscape.
Yeah, I think the other thing that I'd add, I mean, I actually agree with that a lot, right? Like, this is, it's gonna, these things, the way I always put it was, everybody likes to complain about value added until you start looking at the alternatives, which all have the same properties, right? And the same issues arise. We just haven't focused on them yet. But in current evaluation, I think a lot of places are doing multiple measures, but once you're for most teachers, they aren't going to have the multiple measures. But to me, one of the big issues is I think of the MET study as about measurement and not management, and actually using these to manage schools. There's nothing in the MET study about how you give feedback based on these measures, and we know from other studies that evaluation and feedback actually seems to have some impact on teachers getting better, right? Similarly, we know these were all measures. This was a measurement project in a world where there wasn't high stakes. There's clearly big open questions. I've already heard some reports about the student surveys starting to look squirrely once you put high stakes on them. And so, there are going to be a lot of open questions as we start using these for stakes and for management, based on how we're using them, that the measures themselves may start having different properties. So we're going to want to definitely follow that.
I think that, Doug, that's an important distinction about the observation scores, and that is, in current evaluation systems, those observations are continuing to be done by the principals or school leaders within the schools, different from how those observations were scored in the MET study, right, by externally trained ETS observers. So, I mean, that's a critical policy distinction, right? And we're already seeing in these new evaluation systems, similar distribution of teacher performance ratings under the observation scores as we observed prior to the evaluation reforms, right? Which is something that you might expect if the principals are the ones continuing to do the observations.
So the last question that I have right now, maybe one that I can address. Do you have a sense that there are a lot of people using the MET data right now? Is there any way to facilitate discussion among users? So Doug and Matthew, you might want to speak to this as well, but I'll say that we have dozens and perhaps over 100 teams working with the MET data right now via the ICPSR systems, and there are hundreds of users right now. So a lot of people are using it in terms of, well, at least in my perspective, a lot of people are using it. In terms of a way to facilitate discussion among users, I really like that idea, and I think that that's something we can discuss here and what role ICPSR can play in that. I encourage you to sign up for our listserv, because that would be, if there's something that we can do, that would be the first place that we'll target. I don't know if the two of you have anything else to say about this.
Nope.
No, I mean, I think your next webinar on early findings will provide some, a bit more about the network of folks that are using this data. I know Rachel Garrett will be talking about our paper in that webinar.
Mm-hmm.
But I think just, looking at the early career folks' work and linking into the network that you all are creating is probably the way to go.
Mm-hmm. Thanks for that question. That's a great one. So we're scheduled for 4 more minutes. So if there are additional questions, please send them in. Okay, looks like that might be it. So again, thank you for joining us, the participants. We're grateful to be able to share this information with you, and big thanks to both Doug and Matthew. We are extremely grateful to you for sharing your knowledge and your information. Join us for the upcoming webinars. I hope you will. Check out our website. Thanks so much, everyone.
Great, thanks.